Basically, it's a very powerful tool for investigating the things we can't see. Basically, it's not a new technique. It's a technique that has been used as early as the 1920s. In the Swiss Alps, a group, just for fun or for a practical experiment, were able to image the depth of a glacier. And in fact, in Antarctica, the technique's been used to image down to 5 kilometres of ice. So when we have something that's very homogeneous or similar, we can image very, very long distances. So basically, in the 70s, it became very, very popular again because we were looking for tunnels in Vietnam and also for looking for landmines and similar buried features. And then we've also used it for mapping pipelines and anything that was a risk. Right now, we have some really advanced technologies. And I guess we've swept through miniaturizing and getting more powerful processing. And now, certainly the case is we can put it on a vehicle, on any vehicle, and drive around and capture our assets under the ground. The real thing that's been holding us up is the data, is managing the data. When we take a lot of measurements with radar, we generate a lot of data. So the real change that we've been working hard on is to optimize how we deal with that data and quickly turn it into information. So instead of having specialists who've done 8-year degrees, being able to manipulate this data and turn it into information, we now are working on autonomous ways to deliver that information straight to the people who need it, and an interface which is very familiar to people who use GIS and can turn that data into a 3D map of what's underground. So yeah, just walking around the conference today, so many people have use for this sort of information. The technology is really reliable basically because we have been using it for so long, and basically just going back to the weather forecasting and using the Bureau of Meteorology radar, for instance, which is something I think must be the most clicked on link modern government has ever had. It's reliable because it's based on a physical principle. So it's similar to how we can see with light. The light comes from the sun, bounces off a surface, gets back to our eye. With the radar, it's emitted from a point, travels through a consistent atmosphere, in the case of the radar, reflects and then comes back to the receiver. We track the flights around the world. All the planes are tracked using radar, and it's just got a track record of being consistent and accurate. Now when we turn it into the ground, we point it from the sky into the ground, the situation will change. The ground isn't as consistent as our atmosphere. But when we're looking for imaging things like bridges and concrete structures, the concrete is generally pretty homogeneous, so we get nice consistent images of what's happening that we don't know. It's certainly an area that I think will get a lot more use and availability as we work on our end, which is making it easy to use. Once we can get away from being too specialist with its application, anyone can potentially use it, and that's when we'll start seeing much bigger scale applications. Basically, the important thing is the big change we've seen is a bit like with laser scanning. When it first started, we would have one laser pointing at a wall, measuring very slow. So what we're doing now is having arrays of our radar antennas. Instead of just having a single antenna, we now have complex arrays of antennas, and we can develop quite detailed pictures. Now once we have those detailed pictures, we can really see and have confidence in changes. So we can scan it once and scan it twice and see deformation happening over time. One of the biggest features I've seen is voids, underground voids that form when maybe a stormwater pipe starts collapsing and the soil starts working into it. That's a classic case where radar is really, really useful because we see voids really clearly. Another thing is water leaks and pipes, and given our scenario in Australia of having the need to get more efficient with our water, that's another application. But basically bridge decks and big concrete structures, that's where I see it really coming into its own. And also just our roads and pavements, understanding where our utilities are. Yeah, well the underground environment is something that can influence us in unexpected ways. if I'm, what you don't know is probably the way I would put it. And it's a, yeah, that lack of information or lack of knowledge can come and bite you. And at the end of the day, we pay our rates, we pay our taxes, and when we need to fix things urgently, there's a cost. If we can get our maintenance planned and scheduled, the term unplanned maintenance is something that, well, it happens all the time. I mean, you see a lot of budgets get eaten up by unscheduled maintenance. If we can conduct these surveys in a timely fashion so you can see where things are failing, you can get to them before they fail, before the road needs to be dug up and traffic needs to be stopped, and potentially other assets hit. While we're repairing this thing here, we may be actually damaging something over there. So in my mind, we have a fantastic system in Australia, dial before you dig. You don't have that everywhere in the world, but its accuracy still is not there. So my goal is to really use this sort of technology to improve our understanding of the underground and accurately position where these vital assets are. You know, if we go a day without power, we think our world has ended. Obviously, many people in the world go years without power, but you know, when the power gets taken out, we feel like our civilization has come to a halt. So if we can avoid those things by not having these strikes or these accidents, I think the overall society is improved. And obviously there's the danger of having someone strike an energy cable or a gas cable, and you know, the aftermath of those sort of events can be extremely traumatic. So given that where we are in this day and age with our push to build bigger, better, Cross River Rail, the Metro project here in Brisbane, and any number of projects that will be constructed going forward, the more we can understand about the underground environment before we start digging, you know, the savings will be quite impressive. Well, I think the IPWEAQ, it says it all. Public works. I sort of mentioned it before that I just find local government is where the rubber meets the road. I was thinking about it a lot yesterday and throughout the week, is that we've got the federal government, and that's the army, you know, trade. We've got the state government, and that's kind of hospitals and schools. But the rubber meets the road with local government, and that's the rubbish, the rates, the sewers, and can I build a shed on my house, etc., etc. I think I really want to see local government become a driver for growth going forward. I really think employment in local government is a thing that we underappreciate. Many people say small business is the engine of the economy, but I believe that local government really could be the engine of our economy and still help drive our recovery. And I think that the skill sets that we accept inside local government could be much broader, and you know, it really should be a job that we aspire to in the future. Serving your community. I think it's a really high ideal, and you know, the quality of life just benefits. If you have good jobs available in local government, then we will have strong employment going forward. And again, in the regions and areas outside of urban centres, you have to do a bit of everything, and I think it's underappreciated and it needs to be better resourced. I think it's just, I was looking at the map of Queensland and the shires and how diverse and how large some of these areas are. It's a very hard job to be jack of all trades. So I think some of the technologies that I'm talking about will definitely assist the people in the remote regional areas to do more with less, which is what everyone has to do. But ultimately I'd like to see us do more with more, and actually get a fair share of the resource pie. And again, I'd like to see us spread out a bit from the southeast corner as well. It's be great to see population shift and transition into some of these other areas. It's kind of, if we build it, we will go there, and I think that's the first part. We need to actually build it. You know, make it a viable option for people to exist further than just compressed along the coastline. So, but I guess that's a 20, 40, 50, 100-year plan. But we need to have those plans. We need to start thinking bigger than just keep buying houses in the sort of areas we are at the moment. So, but look, this conference to me is hearing what other people are doing and talking to people in the local government space or the public works space. Public works, particularly the IPWA, is about setting the tone, setting the rules, if you like. for how local government can be performed and how engineering in particular happens. And I think we can already see the benefits from having organisation in that area. So I'd really love to see a higher level commitment from our other tiers of government to focus on public works and how it's executed in the more local sphere. But yeah, no, I really enjoy the conference. I think it's supported by a great crew of exhibitors as well. And I just think there's, we want to see Queensland go forward. We want to see Australia go forward. And I really appreciate the freedoms we have in Australia, and I think a lot of it comes down to the quality of our local governments.